This version of example 6 applies if you've either got a black and white calculator or you've got a coloured calculator which hasn't been updated. And you'll know if you watch the coloured calculator video and your screen doesn't look the same as I'm showing you on that video. So in example 6, we've got this distribution binomial 20, 0.4. So remember, this means we've got 20 trials and the probability of success on each trial is 0.4. Well, before we have a look at the example, I've drawn out what this distribution looks like. Along the horizontal axis, we've got the x values. So this is the number of successes. And on the vertical axis, we've got the probability of each of those x values. So for example, I can see the probability of having 6 successes is just a bit more than 0.12. So we're going to come back to this diagram when we answer this question here. So in part A, we want to work out the probability of x being less than or equal to 7. So if you were to say that in English and describe what that means is we want to work out what's the probability that we have 7 or fewer successes. Well, if you think about the diagram, what we mean here, we want 7 or fewer. That means that we want to work out how much probability is there in this region here, from 0 successes all the way up to and including 7 successes. And what we could do is we could work out what each of these individual probabilities is and add them all up. So we could do probability of x equals 0 plus probability of x equals 1 plus all the way up to probability of x equals 7. And that would give us 0 successes, 1 success, all the way up to 7 successes. Well, we're not going to do that because our calculators actually have a function which helps us speed up this process. So what I do when I answer one of these questions is I always start at 0 and I just write out the integers, the number of successes that we could have. And you don't need to write them all out, I'm just using this as a way of thinking about this. Now I want to make sure that I include the correct x value. So I want less than or equal to 7. So I want to include 7 and I want to go down to 0. And I want to add up all of these probabilities. Well, our calculator has a function in it which helps us do that. If you go to distribution, binomial, PD gives you a specific value of x. First of all, you'd need to change var instead of list, where it says data. And if I wanted a specific value of x, so for example, I wanted the probability of x being 0, then I would just put in 0, change the number of trials to 20, and put the probability of success p to 0.4. And that would give me the probability of one x value having 0 successes. Well, we don't want that feature. We want what's called the cumulative feature. So again, go on distribution, binomial, and CD, where C stands for cumulative. Now, here, where it says x, your calculator can add up all the probabilities starting from x equals 0 up to the value that you enter. So if I put in x equals 7 here, if I change that to 7, x is 7, then and number of trials is 20, probability of success is 0.4, then your calculator is going to add up all of the values, all the probabilities from x equals 0 up to x equals 7. So that's our probability there. So we get that this is 0.416 to 3 sig fig. Let's do a similar thing for b then. So we want the probability of x being less than 6. So again, I'm going to draw out some values. So 1, 0, 1, 2, right, so we want to include the values of x. We want to add up the probabilities where x is less than 6. So that means that we want to include 5 and go all the way down to 0. So I'm drawing out this diagram so that I know that I'm not including 6 when I add up the probabilities. Now on the bar chart, that's basically saying that we want to add up all the probabilities to the left of 6, so from 0 up to 5. So on our calculators, we're going to put our upper x value, as 5. And that's going to add up all the x probabilities from probability of x equals 0 up to x equals 5. And we get that answer of 0.126. And finally in C, this is where it gets a little bit more complicated with the black and white calculators. So we want greater than or equal to 15. So again, let's draw out some values starting at 0. Now, we want to include 15 and go greater than 15. So we want probability of having 15 or more successes. So that's the same as saying we want to go from 15 up to 20. And we want to work out what's the sum of these probabilities here. You can visualize that on the bar chart too. That's basically saying that we want to work out how much probability is there in this region of the distribution. So we would add up each of these probabilities here. Well, we're going to use the fact actually that the sum of all probabilities, all possible outcomes, is 1. So if you added up all these probabilities, you'd get 1. So what we're actually going to use is we're going to use the fact that in order to work out these probabilities here, we can do 1 minus the probability of x being less than or equal to 14. We're basically going to do 1, which is the total, subtract these probabilities here. And that's going to leave me with what's this probability in this region here. So let's write that down. We're going to do 1 minus the probability of x being less than or equal to 14. We're going to subtract the probability in this region here. So our calculators can do that because remember our calculators start at 0 and go up to a given value. So we're going to put 14 as our maximum value. And that the calculator is going to add up all those probabilities from 0 up to 14. Now it's really important that you use the unrounded value of this number. So that's going to be 1 minus 0.99838847. And when we round that to 3 sig fig, we get 0.00161 to 3 sig fig. Now I'm going to actually look at one extra example just because I want to make sure that you understand this concept here. Let's suppose we wanted the probability of x being greater than 11. Well, if we wanted that, let's draw out the x values. So we want x being strictly greater than 11. So that means that we want 12 or more, so 12 up to 20. So our calculators can't do that because our calculators can only add up probabilities starting at 0. So here we're actually going to do 1 minus the probabilities here because remember all the probabilities add up to 1. So if I do 1 minus the probability of x being less than or equal to 11, I'll be left with the probability in this region here. So I'm going to do 1 minus, and I just need to go on the calculator and put in the maximum value as 11. So it's going to go all the way from 0 up to 11, and I'm going to use that unrounded value. And if we round that to 3 sig fig, we get 0.0565. Now, you just got to be really careful when you use this method with your calculator because a lot of the time people make mistakes with doing 1 minus. So I'll always draw out a diagram because a really common mistake here is to do 1 minus the probability of x being less than or equal to 10, for example. So always draw out a diagram.